CMM Coordinate Measuring Machine. For detail, please visit my YouTube channel and please subscribe. What is CMM? The full form of CMM is Coordinate Measuring Machine. It is an advanced measurement machine that works for measure complex and large components. The machine is controlled by a computer or an operator. CMM consists of three axes, namely x-axis, y-axis, z-axis. Measurement is done by the probe attached to a third moving axis. This probe could be mechanical, optical, laser or white light. What is a probe? Probes that make use of physical contact, rather than optical light or lasers, rely on spherical tips made from ruby or another rigid and stable material that won't change size due to temperature fluctuations. Types of CMM. The main types of CMMs are as follows. 1. Bridge CMM. 2. Cantilever CMM. 3. Gantry CMM. 4. Portable CMM. 5. Optical CMM. 1. Bridge CMM. Bridge CMMs utilize a probing system that operates across three orthogonal axes, x, y, and z. These axes correspond to a Cartesian coordinate system and enable precise movement along different directions. Each axis is equipped with a sensor that tracks the position of the probe as it traverses the object being measured. 2. Cantilever CMM. In a cantilever CMM, the horizontal arm extends from a fixed base, and the measuring probe is mounted at the end of the arm. The arm moves along the x-axis, while the workpiece is placed on a separate table. Cantilever CMMs are suitable for measuring larger work pieces that require a greater reach. 3. Gantry CMM. Gantry CMMs share similarities with bridge CMMs, but they are typically larger in size. They are specifically designed to eliminate the requirement of lifting a part onto a table during measurement. Offering comparable levels of accuracy to bridge CMMs, Gantry CMMs are commonly employed for inspecting heavy or oversized components. 4. Portable CMM. Portable CMMs are lightweight and portable devices that can be taken to the location of the workpiece. They typically consist of a measuring arm with articulating joints and a touch probe. Portable CMMs are useful for on-site inspections, measuring large objects, and areas where it is not feasible to bring the workpiece to a fixed CMM. 5. Optical CMM. Optical CMMs utilize non-contact optical sensors, such as vision systems or laser scanners, to capture 3D measurements of the workpiece. These systems project structured light or capture images, and advanced software algorithms analyze the data to generate precise measurements. CMM applications. Used in automobile, machine tool, electronics, space and many other large companies. These machines are best suited for the test and inspection of test equipment, gauges and tools. For aircraft and space vehicles, 100% inspections is carried out by using CMM. CMM can also be used for sorting tasks to achieve optimum pairing of components within tolerance limits. CMMs are also best for ensuring economic viability of North Carolina machines by reducing their downtime for inspection results. CMM advantages. The inspection rate is increased. Accuracy is more. Operator's error can be minimized. Skill requirements of the operator is reduced. Reduced inspection fixturing and maintenance cost. Reduction in calculating and recording time. Reduction in setup time. No need of separate no-go gauges for each feature. Reduction of scrap and good part rejection. Reduction in offline analysis time.